AI is everywhere. It writes, it talks, it automates. From tools like ChatGPT, Gemini to enterprise level automation, everywhere the AI is playing a key role in nowadays, right? So it feels like the future is already here, and there are so many speculations also going on around this AI. It is a buzzing topic right now, right? But here is the catch: none of it works without data, and someone has to engineer the data. So while AI is making headlines, data engineering is quietly powering the entire system. And in this video, I'll show you exactly how to become part of it with a clear, modern roadmap. Hey everyone, welcome to DataSurface. If you have ever wondered how to become a data engineer but didn't know where to start, this video is your launchpad. Let's break down the entire data engineering roadmap into 10 simple steps that will take you from beginner to job ready. Right? Let's start with the step 1, foundations, understanding the data fundamentals. We start with the absolute basics, is data fundamentals. So like if you are absolutely beginner, you are going to start in this data engineering space, I would strongly recommend first you should understand about the foundations, like what is mean by data exactly, how the data is became key element for the today's business, how the data is growing, and basically how the systems are handling this huge volume of data. That's where these databases, data warehouses coming to the picture. You should be familiar with these terminologies, like what is mean by OLTP, OLAP, what is mean by batch processing or stream processing, what would be the data life cycle, and get a high level view of how data flows in real systems. So if you have a clear understanding about these fundamentals, it provide a good foundation for your data engineering journey. So this is where you build your conceptual base, right? Think of it as understanding how the engine works before you drive the car. So let's take a use case of any ride sharing app. Every time customer books a cab, the system records the transaction instantly. That is OLTP. Later, the company analyze all trips data from the past month to optimize pricing. That's where the OLAP coming to the picture. Understanding both helps you design systems that works in a real time and scale with long term insights. Now let's move on to the next step, programming. You will need to hands-on skills. One is SQL is a non-negotiable. These are absolute fundamental for any kind of a role. So like in especially in SQLs, you should be having good knowledge about the joins, CTs, Windows functions, basically how you can filter the data, aggregate the data. You can apply the transformations to logic through mostly this SQL only. Also pair it with Python, focusing on libraries like pandas, basic file handling, and scripting for automation. No need to master everything, just get comfortable. Let's take a use case example. Let's say your company wants to analyze customer complaints, customer feedback. With SQL, you filter out complaint message from the support table. With the Python, you can clean the text, remove duplicates, and categorize them by issue type, which is ready for insights. Let's move on to the next step, databases, SQL and NoSQL. So now that you can write queries, it's time to explore databases. Start with the SQL based ones like Oracle SQL, PostgreSQL or MySQL, then move into the NoSQL options like MongoDB, Cassandra. So understand when to use which and learn a bit about query optimization too. Let's take an use case example. In an online food delivery platform, your order history, payments, and addresses are stored in SQL databases. But restaurant menu, formats, and images are stored in NoSQL databases like MongoDB, Cassandra to handle flexibility. So basically, if you are dealing with the structured data, that will comes under SQL databases. If you are dealing with the semi-structured, most probably, or unstructured, it will go to the NoSQL. Right? Let's move on to the next step, cloud fundamentals. Like you should understand cloud fundamentals as well. So the modern data lives in the cloud. Right? Learn the basics of any cloud platform. There could be AWS, Azure, or GCP. Just pick one to start and understand compute, storage, access management, and how to manage resource efficiently. You should understand these core concepts from any one cloud platform. If you take use case example, retail chain wants to centralize sales data from 100 plus branches. Instead of setting up data centers and every center, they use the cloud platform to store everything and process it at a scale and allow analytics in different cities to access it securely in real time. How simple it is, right? Now let's move on to the next step, data storage, data warehouses and data lakes. So now since you clear about the cloud fundamentals, you have already explored about cloud platforms, what are the source storage services are available. So now this is the place. Now it's time to store data properly. Dive into data warehouses like a Snowflake, Redshift and BigQuery and learn about the data lakes like S3 or ADLS. So you should understand little bit depth about these storage services, how it works, how the data is going to be organized in these storage areas and what type of file formats will be supported by these storage services, and then you can go ahead further how you are going to model the data in this particular data warehouse. You should explore those concepts, right? And if you take use case example like a video streaming company captures raw logs like a pause, play, rewind activity from every device. So first you bring the data into the data lake because this is not a structured data, right? It is a kind of a unformatted data or unstructured data. Then you can clean it and you can process it and then you move to the data warehouses for the analytics purpose so that you can get the insights and you can provide the personalized recommendations to the user, right? Now move on to the next step, data ingestion, right? ETL or ELT tools. So the next we bring data in to this particular storage. Learn both batch and real-time ingestion methods using tools like Airbyte, Fivetran, Azure Data Factory and Apache NiFi, Kafka, right? So as I mentioned, you can use any relevant tools and you can ingest the data into the particular storage. Like if you take any use case example, if any fashion e-commerce brand pulls daily products inventory from suppliers via API, new orders from Shopee and customer feedback from Google Sheets, right? All automatically ingested into their warehouse using tools like Fivetran or Airbyte. So like if you want to get the insights from the data, first of all you want to ingest the data into these particular data storage areas by using any relevant tools for that particular use case. Now move on to the next step, data processing, which is transformation. So once you brought the data into that particular storage, you need to clean the data, right? You need to basically deduplicate the data. You need to apply the aggregations as per the business requirement to get the best insights from the raw data. You need to process the data, right? Like you can use tools like Apache Spark and PySpark comes for batch jobs and Kafka or Flink for streaming. Also learn how to write a transformation logic and use tools like DBT or Databricks to manage it all, right? You should explore in these areas. Let's take a kind of any use case example. In a traveling booking app, customer names, cities and travel dates often comes with the errors or mixed formats, right? A Spark job standardize the city names, fixed dates formats and enrich the data with country codes ready for reporting, right? Basically you are just transforming the data and make it ready to use, right? Move on to the next step, workflow orchestration scheduling pipelines, right? So now the time to automate your data workflows. Learn how to schedule and manage pipelines using tools like Apache Airflow, Prefect or DBT Cloud, right? Understand DAGs, retries, altering and even event based triggers like those powered by the Kafka, right? So like you understand the data storage, then you ingested the data into the data storage and you have processed the data. So now basically you are going to automate in this workflow orchestration, right? Let's take any use case example like a media company schedules a pipeline every morning to ingest content, views, calculate trending videos and refresh the home page in real time. If anything fails, they might get the alerts as well to the team, right? Let's move on to the next step, data governance, which is quality and security. So the data engineering isn't just about building, it is also about trust. Learn the basics of data quality checks, masking, authentication and policies to stay compliant and secure, right? For example, if you take any use case example, any healthcare startup uses the data from clinics and hospitals. They mask patient names, encrypt sensitive fields and set role based accesses to restrict the unauthorized access. So the doctors can see the patient history, but marketing teams, other teams only see the insights. They won't be able to get the complete information because that is a sensitive information, right? Now we have reached the final step, version control. Finally, bring your engineering mindset, learn version control with the Git and CI/CD practices using GitHub, Actions, Jenkins or Azure DevOps. This ensures your code and data workflows are reliable, tested and production ready, right? So for example, like if you are working in a particular model or particular workflow, particular pipeline, like your teammates also working in the same pipeline, right? So it shouldn't break something like whatever you are working by with other team members, right? So that's where this code deployment or DevOps will helpful. Like you can independently push your changes into that particular repository. Similarly, your teammates also, they can push their changes into the repository. So the finally that repo will have the complete code from starting to ending. That complete workflow will be stored for the reference. There you go. That's your 10-step data engineering roadmap from zero to cloud ready modern day builder. Now, like you might think there are so many tech stack are involved, so many steps are involved. Let's simplify this. Like what would be our actionable goals if you want to become a aspiring data engineer, right? Like first you should understand the data fundamentals. That's where you should understand about the key terminologies about databases, data warehouses, SQL or NoSQL. Then like a pipelines, all key terminologies, whatever we'll use in the data engineering space. Then you should focus on the programming. Start with the SQL. Then you should understand fundamentals about Python, few of the libraries. Then you can start exploring the data infrastructure and storage. Like you should get the cloud platforms fundamentals like AWS, Azure, GCP. In from warehouse standpoint, you can start with the Snowflake. It is another interesting concept. And data lakes, S3, ADLS, Delta Lake. So you need to focus more about these storage services. Then you need to focus on the data processing and transformations, batch processing, streaming data, all ETL, ELT tools. You should understand this, when to choose which one, when to pick which tool. Then you should understand about the data orchestration automation, then code deployment. Then you should understand about the data governance, how you can safeguard the data. So basically you should take a look at each and every aspect. You can pick whatever you are comfortable, one tech stack, and you should understand from beginner level to intermediate level. That would be enough to landing into the data engineering space, right? If you found this helpful, don't forget to like, subscribe and check out our full playlist where we break down each step in detail. I hope this give you not just a direction, but a real clarity on how to move forward one step at a time. Whether you are just starting out or switching career, remember, you don't have to learn everything. You just need the right path. Now you might be wondering, what's so different about this roadmap? Everyone is saying the same thing, right? Well, the real difference starts here. Check out the next video referring on the screen to find out the answer. Thank you. See you in the next video.